For today's lesson, we will be discussing about the graphs of secant and cosecant functions. So in the previous discussion, we had the graphs of sine and cosine functions. So this time, we will be tackling the graphs of secant and cosecant functions. So before we proceed with the graphing, let's just recall that the graph of sine and cosine functions looks like a wavelength. Okay, and they are just similar with one another. They just have different starting points. And also to remember, sine, cosine, secant, and cosecant, they are reciprocals of one another. So we know that cosecant is just the reciprocal of sine, and secant is the reciprocal of cosine. Now, it has something to do with their graphs. So later on, we will try to compare the graphs of the two, and we will see how this will affect now the properties of our graphs. So let's have here first the graph of cosine x. So we already discussed this. This is the graph of our cosine x. So it looks like a wavelength like this. So for our secant, since it is the reciprocal of our cosine, so that means our graph should be here on the place where the graph of cosine is not located. So let's try to plot here the graph of secant x. So this is the graph of our secant. So as you can see, there are graphs above and below our cosine. So again, this is the graph of our cosine and its reciprocal, which is secant x. Now take note that secant is the reciprocal of our cosine. So if you will look here, this point 0, 1 means that if the angle is 0, then its cosine will be 1. Since it's 1, then the reciprocal of 1 is just 1 also. So that means if the angle is 0, its secant will also be equal to 1. Also on this point right here, given that the angle is pi, so if we get the cosine of that, that is negative 1. If we get the secant of that, the reciprocal of negative 1 is still negative 1. So its secant value is also negative 1. However, on these points here, for example, we have this point, pi over 2, and also 3 pi over 2. So in pi over 2, the cosine value is 0. In 3 pi over 2, the value of cosine is also 0. Now, how will this affect now our secant value? Again, take note that secant is the reciprocal of cosine. So we have to get the reciprocal of 0. And the reciprocal of 0 is 1 over 0, which is undefined. So that means if the angle is pi over 2, for example, and also 3 pi over 2, the secant value of that will be undefined because we have to get the reciprocal of 0. Now, what does it mean if the values are undefined? So if the values are undefined, that means these values are not part of our graph. So if I would try to put x over 2 here, we have the negative pi over 2. We have the 3 pi over 2. Let's also put this 5 pi over 2. So this is where our cosine will be equal to 0. And if our cosine is 0, that means its secant will be equal to undefined. So that means we now have restrictions for the graphs of our secant functions. So what will be the restriction? So the restriction will be those values that makes our cosine equal to 0. So just have to take note of that. That means we will not be considering all the values of x for the graph of our secant. So this is true also for the graph of cosecant. So let's try to see the graph of our cosecant function. So let's graph first the sine. So this is our sine x. Then this is our cosecant x. So it's similar with our secant function. So same as with the secant, some values here will give us undefined value for the cosecant. For example, is this point, 0, 0. So if the angle is 0, its corresponding sine value is 0. And if we have to get its cosecant, that means we have to get the reciprocal of 0, which is again undefined. Same goes with pi over 0. So for pi over 0, again, its sine value of pi is 0. That means its cosecant value will be undefined because we just have to get the reciprocal. So again, we have restrictions here. So if we will put here the x equals 0, x equals pi. So you will see these are the restrictions for our graph, meaning these angles here should not be part of our graph. So even if you go up here, they will not intersect at that line. So that is one thing that we have to consider for our graphs of secant and cosecant function. Now for the general form of our secant and cosecant function, so we will just be following the same as with the sine and cosine. So it's like this. So you have a secant of b times x minus c plus d. And it's also the same as with the cosecant. So the values of a, b, c, and d plays a big role in the graphs and also the properties of our function. Now let's discuss the properties of the secant and cosecant functions. So for the domain, so as you noticed a while ago when we analyzed the graphs of our secant and cosecant functions, there are some restrictions. So those restrictions is when the value of x will give us an undefined value for the cosecant and secant. So that means the domain for our cosecant and secant, we have to identify the restricted values and we have to exclude it from the set of real numbers. So technically, we just have to remove those values of x that will make our sine equal to 0 for the cosecant. Because if sine is 0, that means its cosecant will be undefined. So in order to solve that, we just have to follow this formula. So we have here x is element of real number such that x is not equal to c, plus then we have here k, which is a variable, and then pi over absolute value of b, where k is element of integers. So these values here, this equation right here, this one tells us the restriction or the restricted values. So these values here are not part of our domain. Those are the things that we have to exclude from the set of all real numbers. For the secant, it's also the same concept. So we just have to remove those values of x that will make our cosine equal to 0. Because if cosine is 0, then its corresponding secant value will be equal to undefined as well. So to solve that, we again have here x is element of real numbers such that x is not equal to c, plus then you have k and then pi over 2 times absolute value of b. But this time k is an odd integer. So that is how are you going to identify the domain of our secant and cosecant functions. For the range, so it's the same formula, or we just have the same formula for the range. So it's from negative infinity to d minus absolute value of a included, union with d plus absolute value of a up to positive infinity. Remember, with our sine and cosine functions, during our last discussion, we just identified the highest and the lowest point of the graph, and then this will be the range. But for the secant and cosecant, take note that there are graphs above and also below our function. So that means these points here, these are the highest and the lowest value of the graph above and below. So that's why we have here union, because we have to consider the values here up to positive infinity and the values to negative infinity. Now let's try to solve for the domain and range of the given function. So all you have to do is just to identify the values of a to d and then substitute it to the corresponding formula that we have. So in this case, a is equal to 1, b is equal to 3, c is equal to pi over 4, and then d is equal to 1. Now since the given function is secant, that means the formula that we have to use for domain is x is element of real numbers such that x is not equal to c, plus then we have k pi over 2 times absolute value of b, and k is an odd integer. So once you already determine the formula and the values, all you have to do now is to substitute. So x is element of real numbers. Then we have x not equal to, then substitute c, which is pi over 4, plus And then you have the k, and then right pi. K here now is a variable. So we can just substitute any values here as long as it's an odd integer. And then we have 2, and then absolute value of b. So b is 3. So k is an odd integer. And then just simplify this. We will have x is element of real number such that x is not equal to pi over 4 plus, then we have k, and then pi over absolute value of 3 is just 3, so times 2, that will be 6. And then k is an odd integer. And then that's it. This is now the domain of our function. So any real numbers can be used as long as it will not satisfy this given condition. So all the values of x that will satisfy this restriction right here should not be part of our domain. So that is now the domain of this given function. Now for the range, we just have to follow the formula negative infinity. Then we have d minus absolute value of a included union with d plus absolute value of a to positive infinity. Then we have here negative infinity, and then d is 1 minus absolute value of a. Our a is 1 as well. And then union d is 1 plus absolute value of 1 positive infinity. And then all you have to do now is to substitute, or all you have to do now is to simplify. So we have negative infinity, and then 1 minus absolute value of 1, that is just 0, union with 1 plus absolute value of 1 is 2, then up to positive infinity. So this is now the range of our function. So if you will graph this, so we have here, can be like this. So the graph is something like this one. So what does our range mean? That means the highest point of the graph below is 0. So it's here 0 up to positive infinity, up to negative infinity. And then the lowest point of the graph above is 2. Then up to positive infinity. Okay, so that will be our range. And then for another example, let's have this given function. So let's identify again a. So we have 2. Then we have b is 2/3. C is pi over 4. Remember our formula, it's x minus c. So that's why we're just getting positive 4. And then d is positive 2. So for the domain, since it's cosecant, so the formula that we have to use should be x is not equal to c plus, then you have again the k and the pi here, but this time it's only absolute value of b on the denominator, and k is element of integers. So just substitute. X is element of real numbers, then we have x is not equal, then c is pi over 4 plus k is a variable, so just write k, also pi, and then absolute value of b. So our b is 2/3. And you write k is element of integers. Now we just have to simplify this. Since this one is a complex fraction, we have to get the denominator, get its reciprocal, and multiply to the numerator. So it will become like this. K and pi multiplied to 3 over 2. So therefore, we will have 3k pi over 2. So that will be now our domain. So let's write x is element of real number such that x is not equal to pi over 4 plus 3k pi over 2. And k is element of integers. So this one now is our domain. Now for the range, so let's just get the values again. So we have here negative infinity, and then d is 2 minus absolute value of a, which is 2, included. Union with, then we have d again, which is 2 plus a, so absolute value of 2, and then positive infinity. So this will become negative infinity. 2 minus 2 is 0. Union with 2 plus 2 is 4 to positive infinity. So this is now the range of our function. So the highest point of the graph below is 0 and the lowest point of the graph above is 4. So that is how you solve for the domain and range of secant and cosecant function. So in secant and cosecant functions, we also have what we call as the period. So it has the same concept as with the sine and cosine. So for both the cosecant and secant functions, in order to solve for the period, we just have to use the formula 2 pi over absolute value of b. So just identify the absolute value of b and then that's it. We can identify the period. So let's just get this example and then identify the period. So this will be two pi over absolute value of b. So our b here is 2/3. So we will have 2 pi over absolute value of 2/3. And since it's a fraction in the denominator, so we have to get its reciprocal and multiply it to the numerator. So you can cancel this. So we have 3 pi as the period of this given function. Same as with this one. So for the period, so it's 2 pi over absolute value of b. Our b is 3, so absolute value of 3. So if you cannot simplify it even more, so just write 2 pi over 3. So that is the period of our function. And lastly is for the asymptotes. So the asymptotes, if we are going to recall, this is a line where the graph just approaches or keeps on getting closer, but they will never intersect. So as you noticed a while ago, when we analyze the graph of secant and cosecant, there are some restrictions. And those restrictions, they produces a line. And the graph of our secant and cosecant will not or should not intersect those lines or points. So that's the reason why we have asymptotes for both secant and cosecant functions. Now, to identify the asymptotes of the cosecant and secant functions, we're just going to use the same formula that we used in the domain. Because in the domain, we are getting the restricted values, or we want to remove those values from our domain. So it's just the same as the asymptote. So if you want to get the asymptotes of cosecant function, so this is the formula that we have to use. So again, this is the formula that we have to use for the cosecant of our function, or for the asymptotes of cosecant function. And for the secant function, so we will be using this formula. So you have to include also the k is an odd integer, because that will define the values of k that you have to use. So all you have to do is just to identify the values needed, and then this will give us now the asymptotes, or the equation, general equation for the asymptotes of our function. So let's just try this one example here. So if you already know the domain, you can just get there the restriction, and that will be also the equation for the asymptotes. So just to give you an example, so since this is secant, so the formula will be x equals c plus, then you have the k, and then the pi over 2 times absolute value of b, where k is an odd integer. So what we will do here is you just have to substitute. So we have x equals, then c is pi over 4 plus, and then you have k, and then you have pi over then 2 absolute value of b. Our b is 3, and then k is an odd integer. And to simplify this, we now have x equals pi over 4 plus, then k pi over, then multiply this, we will get 6, and k is an odd integer. So this is now the equation for the asymptotes of our function. Now you can assign any values of k as long as it's an odd integer, and then you will get an equation of the asymptote. So for example, 1. So if you substitute 1 here, so one equation of asymptote is pi over 4 plus pi over 6. If you get 5 as the value of k, so another equation of our asymptote is pi over 4 plus 5 pi over 6. So the reason why we set k, or we put k, is because there's a lot of possible values for our asymptotes. Because as what we know, the graphs of our secant and cosecant are infinite, or it extends on both sides. So there are a lot of asymptotes to consider. That's why we are just creating a general formula. Now let's identify domain, range, period, and asymptotes of some more functions here. So let's start with this one. Y equals negative 2 cosecant 3x plus pi. Okay, so as you notice here, the b, which is 3, is not factored out. And if you will go back to our general form of our secant and cosecant, the b should be factored out from x minus c. So what we will do is we just have to factor it out also here. So you have negative 2 cosecant, and then let's factor out 3, and then divide 3x and pi by 3 so that we can get the remaining terms. So this will become x. Again, we just factored out 3 plus pi divided by 3 will get pi over 3. So this is now the value of b. We have the c and then the a. So let's write here, a is negative 2, b is 3, c is negative pi over 3. Now why is it negative? Because originally our form is x minus c. So since this one is x plus pi over 3, that means the pi over 3 should be negative. And then for d, it's just 0. So now let's solve for the domain. So for the domain, since this one is cosecant, so the formula is x is element of real number such that x is not equal to c plus, and then you have k pi over absolute value of b, where k is element of integers. And then let's substitute x element of real numbers. Then we have x is not equal to, and our c is negative pi over 3 plus just write k, and then you also write pi, and then for the denominator, absolute value of 3. And then just simplify this. So the domain will be x element of real numbers such that x is not equal to negative pi over 3 plus k pi over 3, where k is element of integers. So this is our domain. For our range, so we just have one formula for the range, so that is negative infinity. Then you have to get d. Our d here is 0 minus absolute value of a, which is negative 2, included union with d plus absolute value of a up to positive infinity. And then all you have to do is to simplify this. So the range will be negative infinity, 0 minus absolute value of negative 2. So that will be 0 minus 2, or negative 2. Union with 0 plus, oh, this one should be 2, negative 2. So 0 plus absolute value of negative 2, so that is just 2 to positive infinity. So this one now is the range of our function. For the period, so that is just 2 pi over absolute value of b. And our b is 3. So let's write here absolute value of 3. Or if we simplify this, this is just 2 pi over 3. So that is the period of our function. And for our asymptotes, you can solve using the formula, or you can just simply get this one, the restricted values for the domain. And then that will already be our asymptote. So x equals negative pi over 3 plus k pi over 3, where k is element of integer. And that already be our asymptotes. So that's how you identify now the domain, range, period, and asymptotes of our function. And for our last example, let's just have this one. So like what we did with our previous example, we also have to factor out the b. So we have here 2, factor out 2 here, so we have x plus, and then pi divided by 2 is pi over 2. And then plus 1. After you factor out b, we can now identify the values. Negative 3, we have 2. For c, it's again positive, so that means c is negative. Negative pi over 2. And then d is equal to 1. Now solve for the domain. Since this one is secant, so we will be using the formula for secant. So that is this one right here, wherein we have 2 on the denominator. And k is an odd integer. Substitute the values. X is element of real numbers such that x is not equal to, and our c is negative pi over 2. Plus, for the denominator, 2, absolute value of b. b is 2 as well. And then k is an odd integer. And then simplify, so that means our domain will be x is element of real number such that x is not equal to negative pi over 2 plus, then k pi over 2 times 2 is 4, where k is an odd integer. So this is now the domain of our function. So for the range, so just apply the formula as well. Negative infinity, our d is 1, minus absolute value of a. Our a is negative 3. Included, union with, d is 1 plus absolute value of negative 3, positive infinity. And then simplify. We have negative infinity, and then 1 minus absolute value of negative 3, so that will be 1 minus 3 or negative 2, union with 1 plus 3 or 4, and then positive infinity. So this is now the range of the given function. For the period, so it's 2 pi over absolute value of b. Our b is 2, so absolute value of 2. Or if we simplify this will be cancelled. So we will be just having pi as the period of this given function. And lastly, for our asymptotes, you can just get again the restricted values in our domain. So we have x equals negative pi over 2 plus k pi over 4, where k is an odd integer. And then that's it. That will now be the equation of our asymptotes. So that's it for today. I hope you learned something about the graphs of secant and cosecant functions, as well as their properties, and how to solve for the domain, range, period, and asymptotes of the functions, and see you next time.